A prime factorization of a number is a factorization. Remember, factor means things that are being multiplied, in which every factor is a prime number. So basically, for prime factorizations, you're taking a number and rewriting it as a multiplication involving prime numbers. There are two methods for finding prime factorization. The first is by a chain of long division. So start with the first prime you can think of, 2 is usually the easiest, and see if you can divide your number by that prime. 2 goes into 48 and leaves us with 24. Continue this process. You can divide 24 by 2 and you get 12. You can divide 12 by 2 and you get 6. You can divide 6 by 2 and you get 3. You can't divide 3 by 2, but you can divide it by 3 and you get 1. Your goal is to continue to divide by prime numbers until you get to 1. It is very helpful if you know the first several primes. The first several prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and 23. Though there are many primes beyond that, those are the primes you will see in this class. I would write those down on a note card and have them handy when you're doing your homework. So, at this point, we've divided by primes until we got to 1. Our prime factorization are all these numbers in green. 2 times 2 times 2 times 2 times 3. If you multiplied these all together, you'd get back to 48. Note 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 3 is 48. This is your answer. Notice there are multiplication symbols in between them. This is the prime factorization of 48. Another example. Find the prime factorization of 225. Notice we cannot divide 225 by 2. That's our first prime. So next try 3 or 5. We will use 3. 3 goes into 225 and leaves us with 75. 3 goes into 75 and leaves us with 25. 25 cannot be divided by 3, however it can be divided by 5. 5 goes into 25 and leaves us with 5, and now we can divide this by 5 and we get 1. Again, your goal is to keep dividing until you get down to 1, and you are dividing by prime numbers, 2, 3, 5, 7, 11, etc. Our prime factorization is 3 times 3 times 5 times 5. A quick note, you could have started with 5 instead of 3. That's okay, you would eventually get to the same answer. Also, there's a quick shortcut to see if a number is divisible by 3. Add up the digits. 2 plus 2 plus 5 adds up to 9. Since you can divide 9 by 3, I know I can divide this by 3. Likewise, 7 plus 5 is 12. I know I can divide 12 by 3, therefore I can divide 75 by 3. Whereas if we get to 25, 2 plus 5 is 7. I can't divide 7 by 3, therefore I can't divide 25 by 3. That is a very quick shortcut to determine if a number is divisible by 3. The other method to find, quick note, when you're using the division method of factoring, the last quotient will always be 1. Do not list 1 in your prime factorization because 1 is not a prime number. Okay, the second method for finding the prime factorization of a number is called a factor tree. Take your number and divide it by the first two things that pop into your head. For example, you could use 6 and 10, or you could use 2 and 30. In this case, we'll use 2 and 30. Then continue this process dividing until you get to primes. 30, you could use 3 and 10, or 2 and 15, or 6 and 5. In this case, we'll use 2 and 15. 15 can be divided by 3 and 5. When you hit a prime number, I would circle it. So our prime numbers that we've circled are 2, 2, 3, and 5. You want to continue doing this system until all your n numbers are prime. Then your prime factorization is 2 times 2 times 3 times 5. A quick note, the book and myself will always write your prime factorization in numerical order. It isn't actually important, however, because we're multiplying, and the associative property tells us that when we're multiplying, order doesn't matter. And the last example, find the prime factorization of 72. Again, start with any two combinations you can think of. If not, always start with the small prime numbers like 2, 3, or 5. In this case, I know I can divide by 2 because it is even, and it is 2 and 36. 36 could be 6 and 6, or 9 and 4, or in this case we're going to use 2 and 18. 18 again has several options. You could do 3 and 6, you could do 2 and 9. In this case we'll use 2 and 9. And then 9 is 3 times 3. Again, circle your prime numbers as you get to them, and then write your prime factorization. 2 times 2 times 2 times 3 times 3. That is your answer. Now we'll look at another way to write a fraction in lowest terms. In this case, we're going to use prime factorization. To do this, you start by writing both the numerator and the denominator in their prime factorization form. Then, find the factors in the top and the bottom, the numerator and the denominator, that are the same. You're dividing these to get factors of 1. Lastly, multiply the remaining factors to get your simplified fraction. Example, write 60 over 72 in lowest terms. The prime factorization of 60 is 2 times 2 times 3 times 5. The prime factorization of 72 is 2 times 2 times 2 times 3 times 3. We're going to regroup these using the associative property of multiplication. Remember, when you're multiplying, the order doesn't matter. So I'm going to regroup these and put one set of 2's, put a second set of 2's, and then a set of 3's. Notice the 5 didn't get used, so it's still there, and there was a 2 and a 3 in the denominator that didn't get used. Now I'll use the fact that a number divided by itself is 1. 2 divided by 2 is 1, 2 divided by 2 is 1, and 3 divided by 3 is 1. I'm also going to simplify this multiplication. 2 times 3 is 6. Lastly, multiply by 1. When you multiply by 1, you don't change anything. Therefore, this just equals 5/6. Our answer, therefore, is 5/6. Most people don't take the time to rewrite these fractions as 1. Instead, what they do is they use slashes, and they slash through the pairs on the top and bottom. Note, 2 divided by 2 is 1, 2 divided by 2 is 1, and 3 divided by 3 is 1. And then they multiply. 1 times 1 times 1 times 5 is 5, and 1 times 1 times 2 times 1 times 3 is 6. Be careful when you start slashing that you don't forget about all of the numbers. We jumped from the 2 to the 3 here. Don't forget about that. Our answer is 5/6. Another example. Simplify 18 over 90. 18 can be written as 2 times 3 times 3. 90 can be written as 2 times 3 times 3 times 5. A set of 2's is in common, a set of 3's is in common, and another set of 3's is in common. In our numerator, we're just left with 1 times 1 times 1, which is 1. In our denominator, we have 1 times 1 times 1 times 5, which is 5. Therefore, 18 over 90 simplifies to 1/5. Be careful. This 5 is in the denominator. It needs to stay in the denominator. Had you written this as 5, that would be very, very, very wrong. For example, if I had eaten 1/5 of a pizza, that's not very much at all. Had I eaten 5 pizzas, that's a lot of pizza. And at that point, I'm probably feeling very ill and might need to go to the doctor. Again, our answer is 1/5. 18 over 90 and 1 over 5 are the same value. 1 over 5 is simply in simplified form. Lastly, we're going to simplify fractions that have variables in the numerator and denominator. Note that when you have 3xy, that's the same as saying 3 times x times y. We still have factors, only now some of the factors are letters. Notice how I also rewrote the 9 in its prime factored form, 3 times 3. Again, cross out the things that are same in the top and bottom. Recall that what you're doing is dividing and getting 1's, and then write your simplified fraction. In this case, 1/3. Another example, 4b cubed over 8ab. 4b cubed, 4 can be written as 2 times 2. b cubed is 3b's. 8 is 2 times 2 times 2, and then ab is just ab. There are 2 sets of 2's in common and 1 set of b's in common. What that leaves us with is b squared in the numerator and 2 times a in the denominator. This is your final answer. If we rewrite 7ab squared over n squared in factored form, we get 7, which is prime, times a times b over n times n. There is nothing in common in the top and bottom, so it is already in lowest terms. That does occasionally happen. That concludes section 4.2. Your next steps are to complete the worksheet for section 4.2, then check the key or come to class and we'll go over it, then complete the online homework for section 4.2 through My Math Lab, and lastly start on section 4.3.